NTPC Kanti is located just 10 km away from Muzaffarpur district headquarters. NTPC Kanti reflects the spirit of progress and development of the surrounding area along with power generation. The current generating capacity of NTPC Kanti is 390 megawatt. NTPC Kanti is an epitome of excellence and has become an integral part of the progress of Bihar, and that's why, for the excellent performance in the financial year 2022-23, NTPC Kanti has stood first in Bihar and 10th in Pan-India on plant load factor among the power generation corporations. Water linkage for NTPC Kanti is from the Budhi Gandak river, which is situated about 5 km away from the plant. 45 cusecs of water is allocated by Government of Bihar. Water is pumped to the plant through intake wells and make-up pumps installed at the make-up water pump house at the banks of river Budhi Gandak. The pumped water is stored in the raw water pond. The speciality of these ponds is that it is built using RCC construction, which reduces the seepage of water and mitigates the losses.
NTPC Limited has signed UN Global Compact CEO Water Mandate. NTPC Kanti is committed towards water conservation. At NTPC Kanti, we work on 3 directions. One is reduce water consumption, reuse water, and recycle water. In the reuse front, we at Kanti has successfully converted CW blowdown and ash water, which is accumulated in ash ponds, we are taken back into the plant. In recycling also, we are now converting our STP, means sewage treatment plant water. We also do programs for our stakeholders, then villages surrounding our NTPC Kanti, and in this way, we are drastically reducing our specific water consumption. As per NTPC standards, we continue to reduce further, and our commitment towards water conservation.
NTPC has used multi-dimensional structured approaches to conserve water in a sustained manner, creating awareness towards water conservation, issuance of policy statements, transparent reporting and audit mechanism, digital initiatives for real-time water monitoring, voluntary disclosures, modifications through in-house engineered schemes, process optimizations through performance optimization groups, use of advanced technologies such as ZLD.
MTPS has always shown keen interest in adopting upgraded technologies for energy and water conservation. Post-commercialization of our Stage 2 units in 2017, specific water consumption has shown a reducing trend, and same has been reduced to the tune of 25%. We have a system in place for daily monitoring of water consumption through flow meters installed at various points, designated place, and real-time water dashboard for better monitoring and control. We have been proactive in implementing the recommendations came through the structured analysis and audits to conserve water, and we are hopeful to reduce our water consumption by further 5%.
To enable real-time monitoring, water flow meters have been installed at designated process locations and their readings are displayed in the main plant control room. Further, flow meters are hooked up to the server and a simplified water dashboard has been created to display real-time water consumption. To recover and reuse water from ash ponds, the AWR scheme was studied and developed in-house. This has enabled the recovery of water from ash dikes, and in turn, fresh water intake has been reduced. Through an in-house modified scheme, dry ash is being collected from buffer hoppers, which ensures extraction of ash in dry mode and has reduced the loading wet ash evacuation system and further savings of water. Under process optimization, study and analysis have been carried out for the wet ash evacuation system, and thereafter APH and bottom ash hoppers dishing cycles have been reduced, which resulted in saving of water. For the reuse of wastewater from the process, the scheme of zero liquid discharge has been implemented successfully. Under this scheme, effluents from the main plant and DM plant are collected in the ZLD sump, which is further pumped to the wastewater pump house, where effluents from other plant processes, including plant drains, are also collected. This wastewater is then treated at ETP and further pumped to CMB, from where it gets reused as service water and fire water. STP has also been commissioned recently. For recharging groundwater, 18-number rainwater harvesting pits have been constructed. Additionally, various water bodies in power plants and townships have been rejuvenated for storage of rainwater, and water is being used from the sources in case of exigencies.